Hi, hello, it's me Rajana. Today I'm going to teach you all about varactor diode. I have included the definition, properties, working principle and also characteristics as well as application of varactor diode. If you have any doubts, please do comment below. Thank you. Varactor diode. Varactor diode is also known as varicap diode, that is variable capacitor diode, and it is also known as tuning diode or variable reactance or volt cap or voltage variable capacitor, that is VVC. Definition of varactor diode is, it is a special case of PN junction diode whose internal capacitance can be changed with the application of reverse bias voltage. That is why it is also known as variable capacitor diode, because the capacitance can be changed with the application of reverse bias voltage. For the varactor diode, there are two important properties. One is they are always operated in reverse bias condition, and second one is they are voltage dependent variable capacitor. According to the voltage, the capacitance of a varactor diode is changed. Here is the symbol of varactor diode, which consists of two terminals, one acting as the anode and the negative terminal acts as cathode. It is similar to that of a PN junction diode, but at the cathode side, two parallel lines represents the two conductive plates, and the space between these two parallel lines represents the dielectric or insulating material, which is nothing but a capacitor. So it's a combination of PN junction diode, and at the cathode side there is a capacitor, and this arrow mark showing it is a variable capacitor. That is, capacitance is varied according to the reverse bias voltage. Next, we'll discuss about the working principle of varactor diode. Let us consider this PN junction diode as a parallel plate capacitor with P as well as N region acting as two parallel plates, and region between this P and N acting as a dielectric, which is nothing but an insulating material, that is non-conducting material. We already discussed about the equation for capacitance of a parallel plate capacitor under the topic capacitor, which is nothing but capacitance of parallel plate capacitor C equal to epsilon A by D. Epsilon is the permittivity of the medium, A is the area of the parallel plate, and D is the distance between the parallel plates. We already discussed about the working principle of PN junction diode under reverse bias condition. Under reverse bias condition, if the voltage, reverse bias voltage is increased, there will be an electric field due to this reverse bias voltage. Electric field direction is from positive towards negative, that is towards this direction, and also there is a built-in electric field in the depletion region from positive ions towards negative ions. Both electric field direction are same, so the resultant electric field will increase. Because of the increase in electric field, which pushes electrons as well as holes away from the depletion region, that is, holes which are virtually positive will get attracted towards this negative terminal of battery, and the electron which are virtually negatively charged will get attracted towards the positive terminal of battery. Thus, the depletion region thickness will increase due to this increased electric field. Depletion layer thickness is denoted by small d. According to this equation, C equal to epsilon A by D. Here D is the distance between parallel plates, which is denoted as D, which is the thickness of depletion region in PN junction diode. Capacitance is inversely proportional to this distance D. Here in this equation, D is the distance between parallel plates, and here D is the thickness of depletion region. So as depletion region thickness increases, C will decrease. From this equation, C is inversely proportional to 1 by D. If voltage, reverse bias voltage is increased, distance, that is depletion region thickness increases. So according to this equation, C decreases. If reverse bias voltage is decreased, this thickness will decrease and thus capacitance will increase. Decrease in capacitance means decrease in stored charge. So we need to keep this reverse bias voltage at minimum to achieve large storage charge. Hence capacitance can be varied easily by varying reverse bias voltage. So varactor diode is also known as variable capacitor diode. Capacitance of a varactor diode is always measured in picofarad, PF. Next we will discuss about the characteristics of varactor diode. Here is the plot between reverse bias voltage and capacitance. If the reverse bias voltage VR is minimum, capacitance of varactor diode is high. As we keep on increasing this reverse bias voltage, capacitance will decrease accordingly. If the reverse bias voltage is high, the thickness of depletion region will increase, so the capacitance will decrease. If the reverse bias voltage is less, the thickness of depletion region will decrease and capacitance will increase. Next is the application of varactor diode. Varactor diodes can be used in frequency multipliers. Also, they are used in voltage control oscillators as well as RF communication system. They are mainly used in microwave circuits, also used in radio as well as TV. Also, the varactor diodes are used as adjustable bandpass filters.